Today we're going to study relations and functions. A relation is a correspondence between two sets. These relations can be presented as tables, charts, mappings, graphs, sets of ordered pairs, or rules. We'll also be studying a special type of relation referred to as a function. A function is a special relation where every element in the first set is matched with only one element in the second set. The first set is referred to as the domain. We can also think of the domain as the input values. The range is the second set, or the output values. So another way to think of the definition of a function is a special relation where every element in the domain is matched with only one element of the range. Our next example presents a relation as a set of ordered pairs. The first thing I'd like you to do is graph the ordered pairs. Remember, the x-coordinate is listed first. That's how far to the left or to the right you go from the origin. And the y-coordinate is listed second. So you can see to graph -4, 0, I moved to the left 4 units and then stayed on the x-axis. -3, 1, to the left 3 and up 1, and so forth. There was 0, -2, 1, 2, and 3, 3. Remember that the domain is the set of first values or input values. Here that will be our x-coordinates. When we list the domain, remember it's a set, so we want to list it from smallest value to largest value and highlight the set with braces. In this case, our domain is -4, -3, 0, 1, 3. The range is the second set. Again, we want to list from smallest to largest, so -2, 0, 1, 2, 3, and enclose in braces. Our final question is this a function? Think to yourself. Remember the definition of a function. A function is a special relation in which every element in the domain is matched with only one element in the range. Is that the case here? Hopefully, your answer is yes. Our next example is also a list of ordered pairs, or a set of ordered pairs. See if you can state the domain and the range. Remember to list the elements from smallest to largest and enclose using braces. Hopefully you were successful and have sets that look like this. An interesting point to note is although 9 shows up in 2 different ordered pairs, we only list it once as part of the domain. Once you've identified an element of a set, you don't have to say it's there a second time. You've already said it's there. I wanted to use this example to show you what a mapping looks like. And with a mapping, what you do is you take the elements in the domain and you list them in one of the ovals, and the elements in the range in the other oval. And then you use lines to show the correspondence between the elements in the domain and the range. For example, 9 is matched with 3 and also with -3. 4 is matched with 2, and 3 is matched with -5. Is this a function? Remember the definition of the function. A function is a special relation where every element in the domain is matched with only one element in the range. Hopefully you said no. 9 was matched up not only with +3, but also -3. And therefore this relation is not a function. Now try your skills at writing the domain and range again. For the relation in the next example, see if you can write out the domain and then write out the range. Notice the elements of the domain, 3, 5, 8, 9, and the range, -5, -3, 3. Is this a function? Now, some of you may have gotten this wrong. This is a function. It's a function because every element in the domain is matched with only one element in the range. If we look to the right, we can see how all the ordered pairs are graphed. Notice every x value is only paired up with one y value. Some students get confused when they see one element in the range that's paired up with more than one element in the domain, but that does not preclude this from being a function. On these examples, what we'd like you to do is look at the graph and to determine if something is or is not a function. So let's think about what that would mean. If something is a function, every element in the domain is matched up with only one element of the range. So every x value can only correspond with one y value. Think about how you could see that on a graph and decide whether A and B are functions or not. I look at A, and anywhere I look, no matter where I look, I can only see one y value corresponding with each x value. So it is a function. But with example B, I can see several spots where I can identify an x value, for example 2, that has two different y values. Therefore, this is not a function. And in C, we need to graph the line y equals x minus 5. A little bit of a review here. Fortunately, we're given the line in slope-intercept form. The y-intercept is -5. The slope is 1. So we can plot a bunch of points and then draw the line to connect them, and we see that yes, this is a function. Notice when I drew my line, I had it extend across the entire graph. That's a good practice. Now for part C, we're also asked what is the domain and what is the range. Remember, domain relates to x values, so we're going to look to the left and look to the right. This goes to the left forever, it goes to the right forever. The domain is all real numbers. We can abbreviate that with that funny looking R. The range, remember, range relates to y values. Those go up and down. If we look, this line goes down forever, it also goes up forever. So the range is also all real numbers. How can you tell if the graph you're looking at is a function? Well, we use a test called the vertical line test. The vertical line test tells us that if any vertical line can be drawn that intersects the graph in more than one spot, the graph does not represent a function. And that makes sense because all points on a vertical line have the same x-coordinate. If that vertical line intersects in more than one spot, that means the graph has two different spots that share the same x value and have different y values. Or there are elements in the domain that are matched up with more than one element of the range. So that is our introduction to relation and functions. Hopefully you found this helpful. Have a good day.